Good morning, my dear students of class 8. In this chapter 5, language of chemistry, so far we have studied symbol, valency, variable valency, radicals and molecular formula. What is molecular formula? Once again we will recapitulate what is molecular formula. Molecular formula is also called chemical formula. This is your nitric acid. If we want to write this nitric acid, we will write HNO3. This HNO3 is the chemical formula or molecular formula of nitric acid. So, we had seen that molecular formula is the symbolic representation of a compound. Here HNO3 is the symbolic representation of nitric acid. Now what are its significance? Here we will see importance or significance, characteristics of molecular or chemical formula. See, this is the chemical formula of nitric acid. What does it say? It is one molecule of nitric acid. HNO3 is one molecule of nitric acid. It represents one molecule of the compound. I had told you one molecule of the nitric acid. In this molecular formula, it is one molecule. Nothing is written means it is one molecule. So it is one molecule of nitric acid which contains one hydrogen atom, one atom of hydrogen and one atom of nitrogen and three atoms of oxygen. So it says the actual number of each kind of atom present in that molecule, in one molecule. It also says about the mass of one molecule of the compound, which can be calculated when if the atomic mass of each atom present in the molecule, if we are knowing. For example, here is your HNO3. It gives the molecular mass. How? It is made up of one atom of hydrogen plus one atom of nitrogen plus three atoms of oxygen. If we are knowing the atomic mass of hydrogen, so atomic mass of hydrogen is 1. It will be 1 into 1. It will be 1 plus one atom of nitrogen. Atomic mass of nitrogen is 14. It will be 14 plus three atoms of oxygen. Atomic mass of oxygen is 16. It will be 16 into 3. Now if we calculate, it comes 63. So 63 AMU is the molecular mass, means it is the 63 is the mass of one molecule of nitric acid. Similarly, if it is carbon dioxide, it is also a compound. It contains one atom of carbon. It contains one atom of carbon plus two atoms of oxygen. Atomic mass of carbon is 12. So it will be 1 into 12 plus 2 into atomic mass of oxygen is 16. It will be 2 plus 32 means it will be 34. Its unit will be AMU. So molecular mass means mass of one molecule of carbon is 34 AMU. Here examples are given. One molecule of sulfur dioxide, it is represented by SO2. The elements present, what are the elements? Sulfur and oxygen. One molecule of sulfur dioxide has one atom of sulfur and two atoms of oxygen. Now molecular mass of sulfur dioxide can be obtained by adding the mass of each atoms. You can see this one. Leave this one. We will see it in the next class. Now, what is chemical equations. If I say chemical equation, it is the symbolic representation of a chemical reaction. Symbolic representation of a chemical reaction. If we say, for example, कि hydrogen reacts with chlorine to form hydrogen chloride. My dear students, if we write HCl, it will be hydrogen chloride, and this is HCl. It will be called hydrochloric acid. If it is in gaseous state, it will be called hydrogen chloride gas. But if it is aqueous, means it is in acidic state, it is acid, it will be called hydrochloric acid. So this was the statement. What was the statement? Ki when hydrogen reacts with chlorine, it forms hydrogen chloride. Now if we write like this, hydrogen plus oxygen, arrow, hydrogen chloride. This is also an equation, but this is called word equation. Here is word equation. Now if we write in the form of symbol, so hydrogen, its symbol is H, but atoms never exist in independent state. So chemical reactions are always written in form of molecules. So hydrogen will be H2, oxygen, this should be chlorine, this is your chlorine, it forms HCl. This is called chemical reactions, chemical equations. So this was the statement we had written in the form of word equation. Now this same word equation is written in form of symbols, which will be called as your chemical equations. Now chemical equations are of two types. First one we will see unbalanced equation. Unbalanced equation is also called as your skeleton. In fact, we don't use this word unbalanced equation. Instead of this word, we use skeleton equation. Suppose if it is hydrogen, when reacts with oxygen, it forms water. Undoubtedly, this reaction is 101% correct. But now if you see on the left hand side of the arrow, this is your reactants, this one is your product. So here are two hydrogen atoms, but here two hydrogen atoms, but here is only one. Where is one more oxygen atom? Where has gone one more oxygen atom? We had studied that atoms can neither be created nor destroyed. It can be changed from one form to another. So in this reaction, one atom of oxygen is destroyed. And if it happens, my dear friends, a new chemistry will start. So on the reactant side, the number of atoms of each element is not equals to the number of atoms of each element on the product side. Such equation is called skeleton equation. Now second type of equation is your balance equation. If you see here, same hydrogen, same oxygen, it forms same water. Once again, here one atom of oxygen is destroyed. So we know that by law of conservation of mass or by law of कि atoms can neither be created. Now if we multiply it by 2, here are 2 oxygen. If we multiply this, now oxygen will be 2 but hydrogen becomes 4. So here we multiply by 2. Now you see there are 4 atoms of oxygen. Here are 4 atoms of oxygen. 4 atoms of hydrogen. I beg your pardon. 4 atoms of hydrogen. 4 atoms of hydrogen. 2 atoms of oxygen. Here are 2 atoms of oxygen. Now on the reactants as well as on the product side, number of atoms of each elements are equal. Such type of equation is termed as balanced equation. So a chemical equation is the symbolic representation of a chemical reactions using symbols of formula of the substance which are taking part in a chemical reactions. We know that the substance which are used for the chemical reactions, they are called reactants, and the substance which are formed after reactions as a result of reactions are called product. So this is the arrow. On the left hand side of arrow we write the reactants and on the right hand side we write the products. For example, burning of coal in air is a chemical reactions. New substances are formed, which new substance carbon dioxide is formed. So these reactions can be represented either a word equation or a chemical equation. See, carbon, this was our statement. It was our statement. But now in short we write carbon plus oxygen. It is your word equation. Heat means when it is burnt, form carbon dioxide. Now if we write the symbol of carbon C, symbol of oxygen O, but here is once again O2. Atoms does not take part in chemical reactions. Molecules take part in chemical reactions. So carbon plus oxygen after burning forms carbon dioxide. In fact, a chemical equation is a short form, shorthand description of a chemical reaction. It saves page, ink, space, time and energy. Now what are the steps involved in writing a chemical reactions? These are the things which we have studied in class 7, 8, even in 6, 7. Now write the symbol of or formulae of the reactants on the left hand side with plus sign between if more than one are needed. Likewise, if we write here, this is your ammonia. We have written the formula of ammonia when reacts with hydrogen chloride. If I am using word hydrogen chloride means it is gas. After reaction means these are the reactants. Now put arrow. Here write the name of the product will be ammonium chloride. Only one substance is formed. If two substances are formed, suppose it is calcium sulfate, when reacts with NaOH will form calcium hydroxide and sodium sulfate. Here two products are formed. So after this arrow, in between these two products we put a symbol plus. Sometimes this plus may be needed or may not be needed. Then write the symbol of formula on the product on the right hand side with a sign plus on the product side if it is needed. Then put the sign of arrow where? In between reactants and product side. Then represent the reactants and product in their molecular form. Atomic forms are usually neither stable nor capable of independent existence. Atomic form means atoms normally does not take part in chemical reactions. Here are some examples. Reaction of lead monoxide with carbon. It forms lead and carbon monoxide. Lead monoxide formula is this, carbon, this. After reaction, this is the symbol, carbon monoxide, this one. Likewise, here is the word equation. Reaction with iron and sulfur, it produces iron 2. Iron 2 means ferrous sulfide. If it is written 3, Roman 3, then what it will be called? Ferric. We had seen in the variable valency topic. Higher is the valency, it will be added. Less is the valency, us will be added. So here iron reacts with sulfur, forms ferrous sulfide. Next one is reaction between water to produce hydrogen carbonate, or it is carbonic acid. This stands for H2CO3, stands for carbonic acid. So when water reacts with carbon dioxide, it forms carbonic acid, H2CO3. Then reaction between calcium oxide and water. Here is your calcium oxide plus water. It forms calcium hydroxide. What is written? Now we will notice that total number of atoms on reactant side as well as product side are equal. So they are balanced equation. But now you see here. Here is your hydrogen reacts with chlorine, it forms HCl. This was the, here is the loss of one atom of hydrogen and one atom of chlorine, but there will be no loss. Atoms cannot be created nor destroyed. So it is unbalanced, means it is a skeleton equation. Just right now I had told you this is the atom, it represents one atom of hydrogen, but this one it represents one molecule of hydrogen which contains two atoms. So in a chemical reactions we cannot write like this because atoms does not exist in independent state. So if it does not exist in independent state, means it will not take part in chemical reactions because hydrogen and chlorine represents atom of hydrogen and chlorine which have no independent existence. So the two reactants should be written as H2 in the molecular form, H2 plus Cl2. So in this reaction number of hydrogen and chlorine atom on the left hand side are not equal. Here are two atoms of hydrogen, here is one atom of hydrogen. Here are two atoms of chlorine, here is one atom of chlorine. So the number of hydrogen or chlorine atom are not equal on the reactants as well as product side. So though it is a chemical reaction, and it is also a chemical equation, but since the number of atoms on each side are not equal, therefore such equation is called your skeleton equation. Here are some more examples. In all the chemical reactions, it in all the chemical reactions means in all the balanced chemical reactions, the chemical reaction follow the conservation of mass. What is conservation of mass? We will see in the next class. See you. Wish you all the best. Bye.